So I did ocean heat as my climate change indicator. So how is ocean heat a climate change indicator? So the world's oceans absorb more than 90% of the Earth's extra heat since 1955. Oceans can absorb large amounts of heat energy with only a slight increase in temperature. This is because water has a higher heat capacity than air. The definition of ocean heat content is the total amount of heat stored by the oceans. And the heat from ocean surface waters influences weather patterns because of energy shifts. Differences in temperature can cause differences in density, which create ocean currents. This can cause change in climate patterns and aquatic ecosystems that depend on certain temperature ranges. The increase in ocean heat content will also increase the volume of water, which will then therefore cause the rise in sea level. What is the indicator supposed to measure and how is it gathered? So to measure ocean heat, they measure the top 700 meters of the ocean, which is nearly 2,300 feet, which accounts for just under 20% of the water in world oceans. The indicator shows trends in global ocean heat content from 1955 to 2015. So how is it measured? The ocean heat content is measured in joules, units of energy. It is measured using a variety of instruments from ships and underwater robots. I didn't know about the underwater robots, so I find that cool. And then when is it measured? Must be carefully adjusted for different measurement programs, and it has been collected from 1960s onwards. Limitations of this climate change indicator. So it can be subjected to biases and uneven sampling over time and space. Different measuring techniques sometimes lead to a different version of the ocean heat trendline. And then to try to correct these limitations, scientists compare with other scientist groups or research groups, seeing if their heat estimate correspond with the sea level change. So this is a graph I got off the EPA website, and it describes the ocean heat content from 1955 to 2015. The lines are independently calculated using different methods by government agencies in 3 different countries. The National Oceanic and Atmospheric Administration, NOAA, is one of these agencies. Australia's Commonwealth Scientific and Industrial Research Organization, CSIRO, and Japan Meteorological Agency, which is MRI or JMA. So another source that I found is the National Environmental Education Foundation, NEEF. The average global sea surface temperature has increased about 1.5 Fahrenheit since 1901. An average rate of 0.13 Fahrenheit per decade. The average global sea surface temperature has been consistently higher during the past 3 decades than at any other time since reliable records began in 1880. Higher ocean temperatures leads to, so this is the effects of the climate indicator, an increase in the amount of water vapor over the oceans. With the increase of water vapor, it can cause a risk for heavy rain and snow events. The potential to shift storm tracks, which I'm assuming from it could be the shifts in current because there's changes in density from an increase of heat, basically, contributes to droughts in some areas, so it's not always flooding. And sea levels can rise from thermal expansion, changes in distribution of marine life, and circulation of deep ocean currents. So here's a graph from that website, and it's just depicting average global sea surface temperature 1880 to 2015. So the difference between the other graph is this one as the temperature, and then it kind of goes further back in years. So you can really see the trend going upwards here. The communities that might use this indicator in a climate action plan. So I was thinking coastal communities could be impacted by rising sea levels and stronger storms, especially from flooding and property damage. Communities that rely on fishing for work. So for an example of this, Maine lobsters are migrating north to find cooler ocean temperatures because some species need a certain range of temperatures. Areas with water insecurity, because this indicator can lead to more frequent droughts. And then scientists studying marine life or meteorologists studying storm tracks. And here are my citations.